Hey everybody, it's Keith with the L1 Automotive Training Channel, and today I'm wearing the right shirt, but also we have a 2020 GMC Sierra Denali. Sorry, it's a high option package truck. It's got the cool trippy rear view mirror camera thing. It's so messes with me so much when we're driving, and it's here from a friend of mine, and it's got a AC performance issue is the best way to put this. And the issue exists only when driving, not at idle. At idle, the AC works great. While driving on the road, it's terrible. So this friend of mine, we're going to call him Mr. J, brought me the vehicle. He works in the industry and is in charge of a bunch of repair shops in the area. So I'll leave it at that. And he says, hey, we got a doozy. I want you to look at it. It's a friend of mine's truck. And he knows it's kind of outside of the bounds of what I think he wants one of his guys to deal with specifically. I'm not sure. Maybe he had one of his guys look at it. So he calls and says, I got a friend that's got this truck, and it's had this problem since he bought it, and which is a few years. And he spent thousands of dollars trying to get it repaired, and it's been at a couple dealers. Do you want to look at this? And I said, absolutely. That was my favorite. Financially, as a shop owner, this is terrible. I should not do this. And if you talk to any business coaches, they'll tell you I should not do this. So he drops it off, and I go through our diagnostic process, which, quick plug for our L1 training stuff, l1training.com. There's an events tab. You can come to a class at our shop, and we'll teach you for 2 days the stuff that we do here. And you can start to come to our training regularly and become a technician yourself that's at hopefully at our level or better. I'd love to see people go and then just take off with it and become amazing technicians. So we get the vehicle in, and we start following our diagnostic process. And for those of you that have seen the class online, it is available online too. The $25 a month gets the class for you. This is where all the comments, by the way, for you at the bottom right here, where it's like, stop talking and just tell me what's wrong with the truck. And that's where all those comments are right now. They're happening at this 2-minute 27 mark. Sorry, bro. If you're here for silver bullets, it ain't going to help you, because this probably isn't going to be your silver bullet, but it will teach you how to approach this. So I drive the vehicle, I replicate the concern. Now it's time to pull some data and just look at it while we're driving to just get a baseline of some stuff, see if anything sticks out. That's where we scan the car, get a whole DTC scan, look to see if there's any DTCs that are associated with a refrigerant issue or an air conditioning issue or a cooling issue or anything that could prevent the AC from working very well. And then we move on to, okay, let's look at data PIDs. So I go in the engine control module, and I see that there is an AC disengagement PID. For every time the AC compressor is disengaged, it gives a reason why, like engine shut off. You'll see engine RPM low, and that's usually because people shut the car off, and so when the engine RPM dies, the compressor shuts off, normal when you shut the car off. Well, in this vehicle, all 8 history data PIDs for it were due to refrigerant pressure too high. I'm like, okay, so now I need to start looking at, is the vehicle overcharged, which it's been at 3 or 4 places. It's very possible. Everyone believes a little bit more refrigerant is better. Newsflash for those that aren't aware, you want to put the least amount of refrigerant as possible in your system because it works much better that way. So maybe that'll be for another video, some AC basics. Anyways, I pull up some data PIDs, and I'm like, all right, I drive the car under the conditions and looking at some data PIDs. So let me show you what I saw. I recorded the data because I don't want to drive around with it this way. So we can be safe about it. I've got engine coolant temperature, so we're up to operating temperature. It was this morning, it was only 84 degrees outside. It's 104 right now. So yeah, fun. And then cooling fan command at that time was 0%. AC high side pressure sensor graphed, as well as AC disable because the AC pressure is out of range, which is not the same data PID as why it's disabled. It's just current exact data. So let's go frame by frame. We're 7 minutes and 9 seconds in, frame by frame. And as you can see, we've got some spikes in pressure, but how much are spikes? It's only 97 PSI. That's the high side. That's way too low to start with. And second of all, look at the spikes. They're up to 495 PSI. Those are pretty close. That's between 370 and 400. I don't think it's even possible for AC pressure to go 97 to 495. That's 500 PSI. So then next, keep going. Aha. So the AC pressure spiked a couple times. the AC compressor shut off. This is when the vent temp started going up much higher. So the engine control module sees that the AC pressure on the high side is way too high, shuts the compressor off, and that creates our lack of cooling capability. So we have to start thinking about what would cause pressure to spike too high. Restrictions. This is a 134A truck, so it probably has an orifice tube. If it was a 1234YF truck, it would have an expansion valve. So we think about those things. We think about compressor problems, and also think about electrical issues that could cause a sensor to read too high. Now, this is a transducer, so it has a power, a ground, and a signal out. Transduces pressure directly to a voltage. It's probably 0.5 to 4.5. It's probably a linear ratiometric sensor that X volts equals X PSI. Most of them are like a 0 to 500 PSI. So typically at, 1 volt-ish, they're somewhere around 100-ish. I don't know what the voltage is on it, but it's probably a 0 to 500 PSI transducer. So what would cause a signal voltage to go too high? Because it's usually up in voltage, up in pressure reading. Well, loss of ground. So, okay, we could have a ground problem, right? There's lots of issues running in this if it's voltage or whatever. So I get out and just do a visual inspection of the pressure sensor. Now, the pressure sensor is right up on top of the engine. This is a diesel, 6.6 L5P truck. And it's right on top. And I'm watching the data, and I can hear the compressor cycling on and off when I'm out of the truck. I jump up, and as soon as I touch the connector, the compressor turns on the whole time, and I look at the data, and the data goes straight back to like 97 PSI. Okay, so now we have multiple issues because 97 PSI is too low on the high side. So I look at the connectors. The pins don't appear to be spread, so I believe it to be a terminal fretting issue. So I put some Stabilit 22 in the connector for the pressure transducer, which is, you can look up what Stabilit 22 is, or Stabilit 22, whatever you want to call it. I'm from Oklahoma. I pronounce things wrong. I spell stuff wrong. I'm a dumb redneck, so sorry. Anyways, so that smooths that out. So I was like, okay, the compressor staying on the whole time out was probably the issue the entire time. So I go ahead and pull the vehicle in, evac and recharge it. It's 0.3 pounds low. It's supposed to take like 1.3 or something like that. So, or 1.4 pounds. I remember what it was. It's 0.6 kilograms. It's 600 grams of refrigerant. My AC machine measured it in pounds. I didn't want to change it over. So when I refilled it, I moved it to grams and put 600 grams back in it. So let's pause here and look at what the data is now. All right, since the issue before was driving it, the AC pressure was spiking, and I had different data pits because this is hindsight, right? This is post-repair. So I wanted to look at different data pits. Now that I narrowed into what the issue was, I wanted to look at AC clutch command on, AC compressor operation, whether it's allowed or not. That's all other inputs it's being looked at, not just pressure too high. Then AC pressure sensor and vehicle speed. So this was a while ago driving at, we're 4 minutes in. Let me just, there we go. Just trying to get some time on the screen. As you can see, there was no spikes in pressure the whole time driving. It all stayed between 130 to 170, 180 PSI. No pressure spikes. Compressor never shut off. That's vehicle speed, driving down the road 50, 60 miles an hour. Got up on the highway a little bit earlier before. Was cruising, we'll see, 40, yeah, 70, 75 mile an hour down the highway. Fantastic. Worked absolutely flawless. It was great. And that's a great thing about the Autel too. I recorded a couple data sets and was just looking at them. I mean, we don't have to graph everything, but you can see AC out of range. There we go. Hold time, no pressure spikes post repair. Fantastic. So that's really the power of understanding how something works and applying a critical thinking mindset and some logic behind what could cause it not to happen. So it's important to understand how an AC system works and go through that process. So that's the magic. That's the magic sauce. It's just, how does this thing work? We have a process. We apply the process. We teach that at L1training.com, $25 a month. I'm trying to get better at advertising my stuff. I get people that message all the time from the YouTube channel, hey, where can I learn this kind of stuff? I'm like, hey man, $25 a month on the website and you can do it. So this was a pretty quick and easy one. I'm frustrated for the client that they've spent thousands of dollars other places and no one looked at data because they went, oh, it's an AC issue. So they evacuated it, recharged, all those things. I don't know why it's low. Maybe it has a leak. We did a vacuum test. We didn't go into leak testing. I went into fixing this issue, this performance issue. I'm going to save the client some time and just say, hey, why don't you just drive it around the way it is? If it starts to degrade in performance, then we'll address a leak issue if it actually loses refrigerant capacity later. But it's been driving with crappy AC this whole time for years. It's probably not a leak. It's probably so many people have hooked to this thing. I can only imagine how many times techs have hooked sets of gauges to this truck, and not 4-port gauges or anything, but regular gauges, and then read the pressures and undid the hoses and then just took a little bit of refrigerant from it each time. And that's probably what happened. I see a lot of vehicles that have had previous AC issues that have slightly low refrigerant that have been looked at a bunch of times and don't have a leak. And it's because people hook up gauges and don't evacuate their hoses back into the system. Shut off the high side, and then and this isn't a perfect loss either. You would need a 4-port set to be able to charge back from the 4-port set back into the system and not lose any refrigerant at all. But even with a regular set of gauges you get off the tool truck or whatever, you can close the high side off, let the AC run, and then open the valve between the two high and low sides and pull as much refrigerant as possible out of the hoses to stabilize the pressure between high and low side in your gauge set, so you're not losing as much refrigerant each time you hook to someone's car. I don't have separate sets of gauges in the shop very often. We have some in there. I kind of got them hidden because I have the guys just hook up a machine, and then that way you can refill the system and the machine will stabilize those for you. There's lots of ways. We have lots of manual sets to do it. All of our vans have manual sets. It's just a different thought process. So there's lots of little pieces to that. So just keep that in mind when looking at vehicles, is think outside the box. Go into how does this work? What symptom is there? Of the symptoms, what things should I look at? And really diagnose the car. And I'm just tired of hearing about other shops throwing parts at cars and not fixing anything. It's just really kind of frustrating. So anyways, hope you like this. Hope you got something from it. We'll see you guys next time. And thanks for watching.